Hi, welcome back to Moose and Chemistry. We're going to talk about electron configuration of cations, lesson 1. Now, calcium is element number 20. So let's go ahead and take care of this, okay? So calcium has an atomic number of 20, and it has a mass number of 40. All right, so now normally calcium has 20 protons, 20 electrons, and of course 20 neutrons. We got the neutrons from the AMU minus the protons equals the neutrons. So that would be 40 minus 20 to give us 20. However, I want you to notice this. Calcium has a +2 charge there. So things are not the way they're going to be. So let me show you what's going to happen with that. Okay, normally when we do calcium's electron configuration for calcium, we would say 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. All right. But however, when calcium has 2 electrons in its last shell, the valence shell right there, right? It's when you have a +2, what that means is calcium's going to get rid of these 2 electrons. So when we do that, now what we're going to have instead is we're going to have a +2 charge like you see right here, that +2 over there. Now, what does that mean? Well, if we got rid of 2 electrons, then of course our electron count is going to change from 20 to 18. So look, you have 20 protons, you have 18 electrons. So if you went 20 minus 18, protons minus electrons, you would get a +2 because that would be 20 minus 18, right? So you get a +2. See that +2? There you go. And there you go, right? It's a +2. Wow. Now, what does that mean about the electron configuration? Well, let's take a good look at that, okay? So, this is the electron configuration for simply calcium above it. So normal calcium is this. So now let's write the new electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6. Notice that we don't have a 4s2 because calcium lost those 2 electrons. So now it has 20 protons and only 18 electrons. So it's got more protons than electrons, so it's going to be positively charged. Oh, it's not that hard, is it? No. All right, now, what about the noble gas notation, just out of curiosity? What would that look like? Noble gas notation? Well, look at this. This is simply 3p6. You see that? All that is the noble gas notation for argon, right? So in essence, the noble gas notation, NGN, for this would be argon. Wow. What about if we had, say, orbital notation? What would the orbital notation look like? All right. So let me go ahead and erase a couple things here. Now remember that Ca plus 2 is going to be 1s2, 2s2, 2p6, 3s2, 3p6. So you're going to have 1s up and down, 2s up and down, 2px, 2py, 2pz. Why that? Because all a space equals 2 electrons. That's the max, right? So if you have 6 electrons, like you do with p, you have to have 3 spaces. All right, so let's go 1, 2, 3, 4, 5, 6. Then we have 3s, of course, up and down. Then we have 3px, 3py, and of course 3pz. 1, 2, 3, 4, 5, 6. But you know what? If you did this and put that up here, you would still have to write a 4s2. But because calcium lost 2 electrons, this 4s2 no longer exists. See? So it now becomes a cation. Okay? Now, that's it for this lesson. You guys be snarly, and we'll see you back here at Musin Chemistry.